Hello, 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 hello. Yes, good morning, everyone. My name is Steven. Yeah, and I'm currently working as a community lead at Kampala Devops Community. So Kampala Devops Community is a group of DevOps, cloud engineers, and tech people who have interest in cloud and technology, even software engineers, that we come together and we share, learn, and connect, right? We grow our network as you because with the limited number of engineers in this country, so we're just building this community to have that place where we can get to, connect, learn, and grow together. Yeah. So this is the fourth session we're having, and it's the first this year. Yeah, and I'm glad to have a couple of guests on the call. They'll be introducing themselves shortly, but for today, we're going to be looking at emerging trends in DevOps and cloud technologies for 2025. Our guest speakers, experienced people, experienced engineers are going to be sharing insights that they anticipate that will take shape only this year. Yeah. So I'm going to take a moment to ask every guest speaker to introduce themselves. I think we can start with Diana. Hello, Diana. Oh, I think
I think
Diana
she's
might
off.
be,
Yeah.
yeah, I think she might be having an issue. Probably I will ask Kelvin to introduce himself.
Yes. So I'm Kelvin Galabuzi. I'm a DevOps engineer by profession. I've been in DevOps for quite a while. I think this is like my sixth year in DevOps. It's quite interesting. I've also held multiple positions before. I've been a cloud infrastructure architect and started out my career as a system administrator before transitioning into DevOps. I'm happy to be here to share with the community and to also learn from many other engineers in this community, and looking forward to a good discussion.
Thanks, Kelvin. Let me ask Rogers. The next. Rogers, you're muted.
Hello, can you hear me now?
Yes, loud and clear.
Cool, cool. So thank you, Stephen, for the warm welcome and the invitation to be part of this awesome community and panel. It's always, nice to contribute back to the community, and you're doing a really great job in this platform. I would also like to thank our audience who have found some time amidst their busy schedules to come here and share the knowledge, learn and unlearn from the community. About myself, I'm Rogers Ochan. I'm a DevOps engineer, and I've been working in the tech space for about 9 years now. And past 5 years I've been mainly focusing on cloud and DevOps. That's basically me in a nutshell, and I'm super excited to be here. Thank you.
Thank you, Rogers. Let me ask Eric to go next.
Yes, thanks, Stephen, and the other previous guest speakers. My name is Eric Kasakya. I'm currently working as a cloud engineer under Bank Group. My career path began largely as a software dev who transitioned to the cloud role, largely driven by maybe the previous challenges that we had faced in my previous workplaces to deploy applications and who to take the responsibility for that. Then throughout that process, I took keen interest in the tools and the process, which was exciting for me to transition into that role, which I've so far currently been working in that position. And I'm excited for this event that we do share knowledge among us, the engineers who are on the call, and then share some learnings which we can then use to further either develop our nation or continent or whichever we are serving currently. Thank you.
Yeah, thanks, Eric. Diana is having a few PC challenges, but I think once she's back, I will take off some time to request her to introduce herself again. But I think in the interest of time, we are going to get this kick started. Yeah, so to get us started, I would like each of you to share with us what you see as the most transformative shift happening in DevOps and cloud right now. How is this shift influencing the path to 2025, and what should our audience be paying close attention to? I think we can start with Kelvin.
Yes. So personally, what I feel like the most transformative shift happening in DevOps and cloud right now is the rise. I think it's been around for a while, but I still see it as something that is transformative. That is the rise of platform engineering tools and basically platform engineering and internal developer platforms. So just to talk about what that is at a high level, it's like it basically focuses on building reusable tools and workflows to abstract infrastructure complexities for developers. So if you happen to work with a team of developers that are working on, that are building the product, especially if the team is big, you find that there are constant requirements of spinning up a specific environment. That could be like a test environment to test out the functionality of the product. And with time, when a product is like maturing, you find that there are different features that are being built at the same time. So you find like maybe there's something to do with finance that they're building. There's something to do with an integration with another company that they're doing. So with that need, you find that developers need to spin up test environments to test all this out. But these environments have to be like isolated in a way. So as a DevOps or cloud engineer or infrastructure person, it's like you find that there are so many requests coming through to create these environments. And from experience, I've seen that with time, the product becomes a bit like software becomes complicated with time, and setting this up from scratch becomes a challenge. So with these internal developer platforms, you create something like a service catalog whereby developers can perform self-service of spinning up infrastructure to test a specific feature that they're working on. So that to me is like a transformative shift happening in DevOps and cloud right now. And it's been around for a while, but it's still like transformative in my opinion.
Yes. Thanks, Kelvin, for that submission. Probably let's hear from Eric.
Well, thanks, Kevin and Steven. So one of the transformative things I think which are happening currently is, I think two things came into my mind. One, I think, which we quite, depending on maybe the kind of projects you're working on, most likely you may have experienced it or not. But one of them is FinOps and a certain bit of that cloud cost. You see, the biggest driver, the biggest explanation or selling point or motivation that was given to companies to move to cloud was it is going to be cheaper than running a data center for yourself. And a lot of companies jumped in and went to the cloud without maybe proper roadmap or proper skill sets within the team and then proper understanding of what. And before you know it, costs are high. You find one project consuming over 10K per month. Just one project. And sometimes not even a big application, sometimes maybe it's a small application, but depending on the understanding on how how the cloud environment is set. Of course, sometimes it is easier to just log into AWS and spin up an EC2 instance, choose the instance type, and before you know it, bills are coming. Now, the rise of FinOps, which is more like an understanding between finance or how much are we spending on this environment vis-a-vis what we should be spending. And a lot of tools or a lot of knowledge that needs to be involved for you to make sure, okay, is this cost really relative to what the application ideally should be spending? Because at the long run, then the people on top who are the CEs or the C-suite kind of, for them, they want to know that probably you used an EC2 instance, which is type E2 media. For them, they want to know this application costs us how much in the cloud and what's our return in the company. Now, it's one of the skill sets that now current teams need to ensure that the tech expense is not being covered 80% by just the cloud environment, which when we're selling it to the CEs, we're selling to them and saying, look, cloud is going to be cheaper. Now, if the bill shows, hey, we are spending more money on the cloud, they will say, what did you sell it as? Was it a lie or it was actually a truth? And some of them is as simple as what are the configurations in terms of the networking, which could actually cause the cost. Or sometimes just maybe the size of the instance which is being utilized. And we find maybe a bigger chunk of it is not being utilized. So that's one of these. So the rise of understanding of the tools to guide teams on how to manage the costs in cloud is one of the transformative shifts that I see in both DevOps and cloud environment. The other one is idea security as code. You see, depending on the scale or depending on the sensitivity and governance and regulations around your industry where you're playing in, security becomes a big and even maybe the size of course can translate into who targets you or which focus the attackers put onto you depending on who you are. As of now, remember the biggest number of people that were mainly implementing security on on-prem devices or laptops, endpoints, network. They know the server room access to everything. And now, overnight, all those things shift and went to the cloud. Now, certain things go unchecked. Issues to do when people were configuring firewalls, sometimes they might forget they don't need it and they just go with maybe a security group, however simple it might be. And now, is this security enough? But now security as code is to try and say, okay, what is the standard within our organization? If we are spinning up a Linux, let me say VM or EC2 instance, what are the necessary things so Porsche can be opened? Now, are you going to wait for someone to come later and check what you opened or not? Now, if security as code, what it enables is that you can actually integrate it within the developer's environment so that when they are pushing code, or even if there's a cloud person is pushing that code to spin up this infrastructure, you are saying you want a load balancer deployed with these ports open. By our policy, do we allow those kinds of ports open? So security as code helps in such a way that before even that infrastructure is deployed, those ports are open, and then it is easier to ensure that throughout your development cycle, security is a key component, and it safeguards your organization against attacks which would have come even if it's a dev environment. So I think to me, those two, security as code, then FinOps, some of the key transformative shifts which are currently happening in our stress that we need to pay very detailed attention to support our organization that will drive growth. Thank you.
Yes, thanks, Eric. So just to clarify, when Eric says 10K, he means $10,000, not UGX. Yeah, so our ask Rogers to come next to make his submission.
Yeah, thank you, Eric. So for me, I think the most transformative shift that's happening in DevOps and cloud right now would be the integration of AI and machine learning into the software development, deployment, and maybe infrastructure management, right? It would be actually a disservice for me not to mention AI because I think most of us here have used AI in one way or the other. If someone here says he has never used AI, then I'll have to tell that person directly that he has used it or he or she has used it indirectly without knowing, right? So this has led to the birth of things like AI ops, right? Like AI ops, where we shall be using like AI tools to enhance and streamline DevOps operations, like operations, IT operations, basically, right? We've the tools like I think K8, K8 TPT. I've forgotten the name of the tool that is used within clusters, Kubernetes clusters, that helps you identify and remediate issues using natural processing language, natural languages, right? We shall also be seeing ML ops. Basically, you're using the same principles, DevOps principles, but applying them to machine learning models, right? Another thing that I think is causing a transformative shift is multi-cloud, right? Like I'm seeing a lot of organizations adopting a multi-cloud strategy, right? Organizations no longer want to depend on one cloud, right? Like if that cloud, is compromised, what will happen, right? Also for resilience, basically. So you'll see more organizations adapting a multi-cloud strategy using maybe Azure for maybe VM, maybe GCP for Kubernetes, for running Kubernetes, right? With that, it comes with some level of resilience and also things like supply chain risks, right? If let's say AWS gets attacked today, right? It will affect, let's say you rely on AWS. That means all your processes, right? Your systems are compromised, right? But if you separate these concerns, you put some of your workloads in AWS, some of them in GCP, you basically have some level of security with that, right? Another thing that I see coming up after the multi-cloud strategy, something called super cloud. Right after you have adopted these multi-cloud strategies, what will be next? Because managing these applications, moving applications between different clouds, it's posing to be a challenge, right? How can we seamlessly move these applications among different cloud providers? So you hear some term called super cloud, right? It will basically have a unified layer or unified platform whereby you'll be managing, it will abstract all these other cloud providers. It will give a level of abstraction, right? You won't be handling the, like say AWS or Azure directly. So you'll be having this super cloud that will give you a single pane of glass, basically, right? You'll be able to deploy your applications and move them seamlessly across different providers. Yeah, those are basically the transformative shifts that I'm seeing. To add on what Galabuzi mentioned, platform engineering is also something that we should keep an eye on. Because after implementing, let's say an organization has implemented all these DevOps practices, uh, what next? So basically, platform engineering is something that you can move to from DevOps, right? If you have this DevOps culture already in the organization, it lays a foundation for something like platform engineering. You start thinking about setting up platform teams that will manage these IDPs, like internal developer platforms, right? So these internal developer platforms, you'll be looking at IDPs as a product, right? Like normally as DevOps engineers look at, let's say, an application as the product, right? But in this way, you have to shift your mindset and think as think the you put the platform as your product, right? This time you're not you're support helping the developers. So you're giving self-service capabilities to the developers. You're abstracting the complexities with the technologies. Yeah, so that's what I can say about platform engineering. Yeah, thank you.
Yes, thanks, Rogers. So our our guest Diana Piloya is also on the call. She's back. She had a few technical glitches earlier, but I think she's going to introduce herself and also make a submission. Yeah, Diana, over to you.
Thank you, Steven. Good morning, everyone. They usually say they save the best for last. I hope that's it this time. My name is Kyanda Piloya. I work as a cloud engineer and solutions architect at Cloud Productivity Solutions. What we do is we basically help companies adopt the cloud and optimize what they're already using for efficiency. So with what has been mentioned, what is disrupting the cloud and DevOps environment, as most of my colleagues have already mentioned most of them, but what I can add on is we are moving from a cloud, we are moving to the low-code platforms whereby we are basically going to drag and drop, whereby you don't have to code first and just do a drag and drop whereby anyone can be able to do that. But basically, my colleagues have already mentioned the rest, so I'll go back to you, Steve.
Yes, so one key thing mentioned over the call was AI. So since then, you're still unmuted. So I would like us to talk about AI. How is AI changing the game in DevOps and cloud? What are some of the predictive capabilities you're able to see? Yeah, could we start with you on this?
So with AI, let me start with cloud. If you're deploying your infrastructure on the cloud, you're able to predict when an issue is about to occur. So that is what AI is able to do in the cloud sector. Then it's also able to help you with the deployments. Let me say you have multiple infrastructure that you'd like to deploy. You're able to generate scripts that you're able to use for the deployment. And in the DevOps, like I've mentioned, the low-code platforms, most of those are actually using AI. So they're able to use AI and help you to be able to get the website, so whichever code you'd like to do for in the shortest time possible.
Yes. Thanks, Diana, for that submission. I'll go back to Kelvin.
Yeah, some Diana shared. So how AI is changing the game, looking at predictive capabilities. So systems can, like Rogers shared, that there's one way or the other that you're using AI. So you find that platforms are, let's say that the big three, that is Azure, AWS, and GCP. So there's also these predictive capabilities. So how AI is changing this is systems can forecast failures, like they can help you forecast failures, performance issues, or capacity bottlenecks if they are to ever occur. So this is kind of like shifting from reactive firefighting to proactive management. One of the things personally that I use is Datadog. So Datadog has this added capability. It's called Datadog Watchdog, that uses machine learning to detect outliers in logs, metrics, and traces. So you can look back, use it quite many times. You can look back and see, something like discrepancies from a specific service, and helps you to tell actually there's probably a problem, or maybe a deployment was made that is causing this. So as you also continue on to see how AI is changing the game in DevOps and cloud, there's also like infrastructure optimization. Eric talked about FinOps. So these days, AI also helps you to recommend cost and performance efficient configurations for those that use a cloud. For example, in Azure, you find there's Azure Advisor. Google Cloud, you find there's Google Cloud Recommender, which can suggest like the right PM sizing. So this offers like personalized ML-backed guidance for performance or cost improvements. There is also it's also there in security as well. So there's a lot that AI is doing. But I'll pass on along to another speaker to add on to that. But it's also doing machine security as well to detect threats, anomalies, and misconfigurations in real time.
Thanks, Kelvin. Eric?
Yes, thanks, Tim, for the maybe just maybe an addition on what they have already shared. I'll go with the one of the most I think which is daily usage. I think AI has helped a lot these days in debugging. You can actually get an error log, which may be a very long stream, and AI can actually be able to point out most likely could be this area where, or it just may be just straightforward the DB or this table is missing in a database which you are querying. So it's part of the tool that we are currently I think many people are adopting to use so that they can easily, even if a language they have never coded in it and they're deploying that application and they return an error log and they have access to it, they can actually understand it even in the absence of the dev who actually developed that application. So on top of what the previous speakers have already shared, issues with security, cost optimization, even in predictability of the capacity, and or maybe trying to use machine learning tools to look at the logs and confirm or predict and say this application is more previous, maybe during this period of time it goes down or the resources are not enough, maybe using the previous data that it has done. But the day-to-day operations which I find many people are using now is when they're having an error and they are unable to maybe figure out where it's coming from. They are using AI tools to be in position to tell where that error could be coming from. Yeah, thank you.
Yeah, thanks, Eric. Rogers?
Yeah, thank you. Yeah, speaking about AI is really actually running the show when it comes to cloud and DevOps, and maybe all aspects of our lives for that matter, right? I, for one, I can't take a day without you opening my chat GPT and, searching about something new or,
Yeah.
clearing my doubts about a particular technology, right? I'm always using this. So it's basically kind of my partner, my go-to, let's say, comrade, yeah, right? Uh, so I've seen AI being used in a number of areas, right? For example, in AWS, you'll see there's something called cost anomaly detection, right? I recently found about it because I was looking through the console and I saw some prompt and there was a lot saying that there's some issue with my course. Like there's some, let's say, an instance that, let's say, I'm going to give you an example. Let's say I have a running instance and monthly I pay, let's say, around $42 for that particular instance, right? Then one of the months, the instant I end up paying, let's say, $50 for that instance. AI will help me detect that anomaly, right? It will inform me. It will be like, this instance has been running and you've been paying this amount of money, but I see the spike, right, in costs. You're now paying $60. So it helps me to detect those anomalies. I think, I don't know what the tool is, but it's integrated into AWS. If you might have come across it.
Yes, it's
Another
part of
thing,
cost management.
yeah. Another thing I've noticed is that there's, I think, AWS Q or something, that chatbot. Yeah, it
The
has
internal
been given
chatbot.
superpowers. I think gone are the days when I was starting my AWS journey. Whenever I would interface with something that I don't understand, I have to dig into the documentation, move into another page, uh, find my way out into, let's say, a solution. But with AWS Q, you can actually type using your plain English the issues or what difficulties or setbacks you're having, and it will give you like a full step-by-step process, structured process which you can follow, right? Like I want to create an instance, it will guide you through it. It's just right there, like you'll have it, it's always accessible, you'll always have it. So I think that's where AI is also helping, let's say, as like the cloud, let's say cloud engineers, cloud architects, cloud operations. Another thing is when it comes to development, basically. These days, when I want to develop maybe Terraform code, like I want templates, I can go to, let's say, GitHub Copilot. I don't know if some of us have used GitHub Copilot, right? It will give us a boilerplate. Basically, it will generate for me the templates immediately. I don't have to start from scratch, right? It helps you. There's also something called Casa AI, which helps you actually. I've seen people use it to generate fully fledged application, full stack application, front end, back end, right? All this in a matter of minutes. Can you imagine? Yeah. So I think yeah, AI. Those are kind of the benefits that we can see with AI. Thank you.
Yeah. I think
Yeah, yeah,
I think I would say, Kelvin, yes.
yeah. Just something that Roger's mentioned. Just curious to know. You mentioned that you use ChatGPT at least almost every day. Yeah, that's interesting. I'm wondering, have you tried cloud before, like cloud AI?
Cloud
Yeah,
AI. Yes. So I've tried the LLMs. I've tried Cloud. I've tried Gemini. I've tried DeepSeek. There's I think, yeah, and ChatGPT, of course. Those are the LLMs that I always use.
yeah. I used to use ChatGPT most times for like coding tasks, but with time I found cloud really brilliant when it comes to coding tasks. Like
Yeah, when it comes to
first,
it's kind of optimized for
yeah,
coding. It's really
yeah.
nice.
First
And
time it's working. Yeah, so
yeah.
As you can see,
interesting.
to engineers out there, AI is really crucial. I think you also talked about Amazon Q. It really summarizes the bill in just seconds, which would take you hours, say, to find out what is happening.
Yeah,
But
right.
to move on, security has been one of the key mission things, and security is always top of mind, right? So in the context of increasing complex cloud deployments, we talked of multi-cloud strategies. We talked of multi-cloud strategies. What do you see as the most innovative security approaches that you've encountered, and those that you think why they're effective? Yes, I think we can start with Kelvin, since we're almost coming
Yes.
to you, actually. Yeah.
Okay. Yeah. So personally, the most innovative security approach I've encountered recently, and it's been talked about. It's quite common, especially when you come in talking about security in the cloud, especially with the adoption of Kubernetes. It's known as eBPF threat monitoring. So eBPF in full is like extended locally perfect filter. It's something in Linux that allows you to run modules in a kernel. It's kind of like running a plugin in a kernel to extend the kernel's capability. So in a nutshell, what it does, it helps to observe like the system behaviors at the kernel level. So basically, before attacks reach the application level, with eBPF monitoring, you're able to detect these attacks at the kernel level, at the core operating system level. So you can detect things such as syscalls, for example, privilege escalation attempts, which are quite common in containerized environments, whereby some containers are going like they're trying to go above their set privileges. So it kind of helps to detect those privilege escalation attempts, and also anomaly detection. So that's like the innovative security approach that I've come across recently. And you find that a couple of tools in the cloud native space, such as Falco, Cilium, which is a container network interface, they kind of use eBPF monitoring as a selling point, because it really goes down deep to the operating system layer, the level that the operating system is working on, the kernel level, to curb threats before they reach actually the application. So yeah, that's like the innovative approach I've encountered recently. But with some reading I did, eBPF, I think it's something that was done in the past. Just it was done in the past, but it was not as improved as it is right now. Yeah.
Oh, thanks, Kelvin. That's a very insightful takeaway for Kubernetes users. day-to-day users. Yeah, I will ask Diana to come in next.
Diana is muted.
Diana, you're muted.
Oh, apologies for that. I was saying one of the security implementations I've come across is the zero trust model or architecture, whereby you verify everything and everyone, because on the cloud, when you're provisioning resources, most of those resources can be accessed by anyone everywhere. So you need to be able to have the zero trust model whereby no one has access to everything at the same time. That's where the zero trust model comes in from. And in the development, there is also the DevSecOps that has come up, whereby when you're deploying your environment, your infrastructure, or doing your code, you have to be able to implement security in each and every layer. So back to you, Stephen.
Yes, probably for this, I will ask Diana something small. There's a quote we have is zero trust. Never trust, always verify. Yeah.
Let's verify.
I will ask Eric to come in next. So there is certain concept around zero trust.
Well, yeah, maybe at first when I had never trust, always verify, I was like, this principle is teaching people not to have trust for people because they'll carry on in life in other areas. But yeah, DevSec is I think one of the other strategies that are currently inclined security to ensure that security is embedded across the whole developer life cycle. And maybe just to, I think maybe just also an addition with what Diana said is that we find that security does not, okay, at different stages of the development life cycle, there are different issues you can unearth. And how quickly you remediate them or stop them from happening will safeguard you either the cost you would have paid if that thing was to actually be shipped into production. It's as easy as someone running, if, for example, if we say we are in a containerization environment, as simple as what are the vulnerabilities within the image, which has been used as the base image, could affect the end user or the current product in terms of security perspective, because a developer just might do whatever they need to do to secure that application. But if maybe at the time of containerizing that application, the base image was used with a vulnerability, which is even known and flagged, then it becomes an issue. Now, the tools which we ideally put into the pipeline or the cycle or the DevSec processes to ensure that those are ideally flagged as immediately as possible before they reach in production. Now, such principles help us to ensure that those areas are affected. But I think maybe the other area hinted on was the one for security as code. So we had already seen infrastructure as code. We had already seen other concept, GitOps and whatever. One that has recently been a key was to ensure that, well, security as code, or to implement security in terms of code. What one of the areas where I found it very very helpful, maybe within our space or the organization I currently work with, was that sometimes in AWS what we call a well-architected framework, which has the principles of what a well-cloud environmental principle has been set up. But then you have what we call company standards. What are your standards? For example, the well-architected framework may say these ports are open, but for you may say port 80 and port 443, which is the HTTPS, are always open on the load balance. But for you may say in our organization, everything must be accessed on HTTPS. Now, infrastructure or security as code would help in terms of that you could actually have the policies or the guardrails coded and embedded. But by the time someone pushes, even just says run a Terraform script or whichever it might be, AWS CDK infrastructure. By the time it clicks to apply that particular deployment, it returns and says, no, we can't deploy this particular resource because this port is open. And the security person does not need to wait and review that particular component later to identify that. So that principle to me has, one, it saves time. Two, it makes sure that even to the whole team on the whole development lifecycle, they actually are aware that, well, once we are setting up this, the standard is we don't have this open and it is known. Of course, the other concept which I think that we talked about, which helps, is to embed them into the modules or to the platform engineering concept to ensure that which are standard, they're already coded. Yeah, so I think that's my submission. Thank you.
Yeah, thanks, Eric. Yeah, I think we were used to infrastructure as code, but through this call, we have had security as code. Yeah, so I'll be moving over to Rogers.
Yeah, so for me, one of the innovative security approaches I've encountered recently is policy as code, right? Basically, you're defining security rules, and these rules get proactively enforced, right? For example, if you're deploying, let's say, a Terraform, let's say you're deploying resources via Terraform, and let's say there's a misconfiguration and it violates, let's say, GDPR data, policies, right? So this will prevent it from moving to production, right? It will prevent it from moving to production, and that way it will help you, keep the posture. Let's say auditing, let's say. With this, it prevents misconfiguration basically, and with this misconfiguration, for example, if you misconfigure an S3 bucket and make it public, these kinds of tools will help you detect that, without reaching actual production before it moves further ahead. Yeah, so that's, I think, one of the innovative approaches that I've seen with security.
Yes. Thanks everyone for those great submissions and insightful submissions on security. But I think some of the key concepts being identified, GitOps, eBPF, so all these are resolving around Kubernetes. So I think my next question resolves on Kubernetes. Kubernetes has become a very dominant force in container orchestration, right? Running containers at scale, right? So to ensure that everyone is on the same page, could you break down Kubernetes at its core? Probably, I think one speaker will break down Kubernetes to its core, but then we shall talk about the primary benefits of adopting Kubernetes, challenges first, and strategies that can enable teams to embrace Kubernetes. Yeah, I think we can start with you, Rogers.
Yeah, so Kubernetes is basically with the rise of containerization and so on, right? Kubernetes comes in as an orchestrator, right? At its core, it's basically an orchestrator designed to maybe automate the deployment of these containers, right? The management, scaling of these containers applications. That's basically it, I think, in the most basic way. That's what Kubernetes is. It's basically an orchestrator, container orchestrator. Yeah.
Yeah, so we can talk about what are some of the benefits of adopting Kubernetes and the challenges faced with implementing it, and how best can we enable teams to embrace Kubernetes successfully.
Yeah, me?
Yes.
Yeah. Okay. So basically, some of the challenges of Kubernetes, benefits basically of Kubernetes, it provides scalability, right? It dynamically scales these applications based on demand. It also, Kubernetes has self-healing capabilities. Whenever, let's say, there is a fault in one of the pods, that's the basic unit of Kubernetes, the basic level unit of Kubernetes. That's called a pod. So these applications are running as pods. So whenever there are issues in these pods, Kubernetes automatically restarts them. That's one of the self-healing capabilities of Kubernetes. Another thing is that Kubernetes is portable, right? You can deploy an application on Kubernetes and run it on, let's say, EKS, but you can move that application seamlessly to something like GKE on Google Cloud, right? So it provides that platform agnostic approach, to your applications so that you can seamlessly move across. Also, one thing that I want to note with Kubernetes is that its ecosystem. It has all these tools that revolve around it, right? We'll talk about Helm, we'll talk about service meshes that add basically extras to your application, like service meshes. They bring in security, service discovery, and all these things. So it's tightly integrated into. It has a very strong ecosystem, and it's tightly integrated into some cloud native tools. CI/CD, when you talk about Argo CD for DevOps approaches and continuous deployment or delivery. Yeah, so I see some of those are some of the benefits I can think of when it comes to Kubernetes. And of course, it has there's some challenges, right, that comes with it also. For example, it's complex, right? Kubernetes is complex. If you're a small team, it's going to be hard for you to manage this system, Kubernetes, right? Because you need it has a very steep learning curve, first of all, right? You have to keep all your team members in check, right? They need to learn all these things when it comes to Kubernetes, and it's so wide. Like, it's not easy. It's not something easy, but it's doable. Also, another thing, since Kubernetes deals with containers, right? Containers historically have been basically ephemeral, right? Kubernetes, by design, they're ephemeral, right? So Kubernetes has a challenge of persistence, like storage, right? So dealing with persistent storage, running, let's say, data in Kubernetes is still a challenge. It's still not fully cracked, but we are getting there. Another thing is maybe since Kubernetes, let's say you're using, also security, right? Most people might be using Kubernetes as a managed service in AWS or any other provider. So there is also a risk of supply chain security. Basically, when these companies are attacked, your applications are also compromised. So those are some of the challenges I see with Kubernetes. Yeah.
Yes. Thanks, Rogers, on that. Kelvin?
Yeah. So I think Roger has spoke most of the right, like the points that it's complicated. It's complicated when you're just starting out with a steep learning curve. That's a challenge. And also, if you're not careful, you may implement something that you can implement like overly permissive, permissions without knowing. So that usually drives back to scaling up, which is one of my strategies that I would recommend for successful adoption of Kubernetes, making sure the team is skilled up on how to successfully operate Kubernetes. Like he has shared, there are still some challenges to do with things like persistent storage, which you find, yeah, that's a challenge that many teams face when they're working with Kubernetes. There's a few workarounds, such as stateful sets. For example, if you're running databases, you use stateful sets. There are a couple of operators for, let's say, PostgreSQL has an operator for Kubernetes, but still, I wouldn't want to put it in a stateful set. I don't want to. So yeah, that's a challenge, but all that comes with skilling up, the team knowing, because if the team is not properly skilled up, they can go and put in stuff in Kubernetes and it becomes a problem. There are some horror stories I've had from a couple of colleagues that have had downtimes. I wouldn't want to share here because this is a recorded session. I don't want to share company secrets for people, but yeah, so I have the same view towards what Rogers has shared in general in Kubernetes.
Thanks, Kelvin. Eric was laughing when you said people who have horror stories. Probably Eric, come next. Eric,
yeah. Well, Kubernetes. So, but it's an interesting tool. It's very useful and has a lot of benefits. But as the previous speaker, Zawake highlighted, that Kubernetes has a high learning curve. And before its adoption, I think maybe part of the challenges which we have, I will begin maybe with challenges, that before a company adopts it, one is have the right skill sets within the team, and ensure that they are always skilled and updated with what's currently happening. And that is ideally refreshing up every now and then, even just for the CK exam. They even keep updating the exam content. They remove some things, they add some things. I think from the recent update, I think they have added Helm and customized as part of the tools which are examined along that exam. But maybe the other advice that I give also is ensure that your application actually needs Kubernetes. Because there are sometimes, I always tell people, let us not use a gun to kill a mosquito. Because there are some applications actually that do not need Kubernetes. If you are running one container, if you only have one service or two, there are other tools you can use. I think for the case of those in AWS, there's a tool called ECS, which can actually do container orchestration, and it will actually serve you better than taking on this giant just for 2 pods for your 2 deployment file. Because if someone tells you what it takes to just expose that application to the end user by you deploying that Nginx ingress control and the like, just to create a load balancer to point it to the application, and someone asks, I saw a meme recently where someone says, I know the application is somewhere, how the traffic is reaching it, which components had to pass through before it actually reaches the actual service of the application. A lot of you may not know, but if you tell someone there's a load balancer here, there's an ingress controller, there's an ingress service, there's a service of the application, now you have a service mesh, now you have a proxy, where did the traffic pass before it actually hit the pod or the actual container inside that pod? Because even on top of saying there's a pod, but there's even a container in the pod. So how did it be able to return that service? So before you actually take on Kubernetes, you need to confirm that you actually need it, because, and how I tell people to know that you need it is you need to know who developed it. What challenges was he facing before he thought about Kubernetes? The person who developed it is Google. What were the problems Google was facing at the time? Which kind of application was he managing? If your application is tending to that direction, you actually need Kubernetes, because it solves a very big problem. Because the problem that which the benefits which it brings is, how do you scale an application easily without having a downtime? Even the other thing is the kind of deployment strategies we keep talking about, blue, green, canary, whatever. They are easier to implement them in Kubernetes, because some of them come by virtue of using Kubernetes. They will tell you how much of the pods will be put down before they roll out a new deployment, just from the some of them as if they are just by default, which is harder to manage in terms of if you are doing your normal deployments without using this particular tool, because it will be harder for you to say, okay, are we going to set up a new server first? We install these tools, then we deploy. It will be hectic. So Kubernetes has you have 1,000,000 customers or thousands of customers. You don't have to tell them, well, the application will be down for 2 hours because you are doing a major upgrade. Kubernetes has a way, if you have already adopted this tool, it will be easier for you to roll out a new update, or even to test. You say, we want this application fast accessed by maybe 20% of the traffic. It will be easier if it has been set it up, or you're using this kind of tools already, and you are able to test that traffic and say, are they receiving errors or they are not? And then you transition the other side. Then, of course, the other thing is that Kubernetes has already even though it's complex and what, but it has huge challenges if you find yourself that you're in a place where you actually need to use this tool. Because things like monitoring, they already have tools which are easier to integrate into the ecosystem to get the logs and even to develop dashboards to monitor what's actually happening within the cluster. So it's a good tool. Yes, it's complex, but once you find yourself that you are using a lot of servers, a lot of containers, just for this particular application, it is easier. It becomes a good tool for you to relieve yourself a lot of duties and a lot of tasks for you to manage this application than if you were doing it manually. But if you find yourself with, you don't need more than one server, you don't need your instances are few, then you are better off choosing another tool to do container orchestration than taking on this giant who is used to solve big problems. Thank you.
Yes, thanks, Eric. I think two key things from your submission is the why and architecting done right. Yeah, but yeah, it's really it's really insightful for the audience. Diana, what are your takes on this? You need to unmute.
For Kubernetes, I think most of my fellow speakers have already mentioned most of the things, but I think that the key thing I say is you need to scale your team in case you want to use Kubernetes, then things will move flawlessly.
Yeah. Thanks for that. So probably since I'm still with you, I think one of the key things talked about is deployment, right? Running something on one server or running something on Kubernetes. But for applications to get to these intended servers or targets, I would say we use CI/CD, right? Container, continuous integration and continuous deployment. So in that regards of CI/CD, what are some of the significant trends you think will define 2025? And are there new tools or methodologies that are becoming essential? Yeah, let's start with you, Diana. Let's take a floor.
Okay, for CI/CD, the tools I see coming up, I'll still go back to AI. There is a lot of AI integration in it. For example, GitOps, if you use GitLab, most of those tools already have AI in them. So for GitOps, you're able to deploy your code and be able to have AI integrated in those as you do your CI/CD.
Thanks for that. GitOps is also becoming really a thing. Yeah, but I think our readers, our listeners will probably have to do further research on that. Kelvin?
Yeah.
You want to take on CI/CD?
Yeah, CI/CD. Yeah, GitOps is the word these days. Using Git as a source of truth for both application code and infrastructure. So I think the couple of tools that are leading the pack is Argo CD and Flux. There's a lot of debate on which to use. Found most teams say if you're working mostly with application code, Argo CD will be the go-to. Argo CD has a couple of features. There's easy rollbacks. It's also easy to audit changes and also implement blue-green deployments. That's like having a blue-green deployment is like having one environment that is like a backup of the production environment in case something happens. So that's the evolution in CI/CD that I'm seeing. I don't see much difference on what has been happening in the past using the old tools. It's just the added functionality that is being added. But that's my view towards the evolution of CI/CD and the new tools that are becoming essential, which is like Argo CD, Flux CD.
Yeah, thanks, Kelvin. Rogers?
Yeah, so CI/CD, basically, I see the trend with CI/CD basically these days is I see people incorporating DevSecOps practices into their pipelines, right? The shift left approach where you're using tools, let's say like Privy for image scanning for vulnerabilities. You have something like Snike also, which is similar. Then I mentioned, I think earlier about policy as code. So you see things like open policy agents running in these pipelines to prevent misconfigurations from flying into production, right? So those are the things that I see being incorporated into the CI/CD pipelines, right? Also, yeah, you guys have mentioned Ready GitOps as a standard practice, using tools like Argo CD, Flax. But I'd also like to add a tool called Crossplane, which will help us in deploying across cloud platforms, like Crossplane. Also, we shall see development of internal developer platforms, which will help us abstract these CI/CD complexities. Right? Developers will not really have to interface with the CI/CD pipelines anymore. They'll have to do self-service through, let's say, a portal. And the tool that comes in mind is something like Backstage. It gives you like a portal where
Backstage by
developers,
Spotify.
yeah. So it gives you basically a service catalog. Developers will have like this service catalog. They'll have to choose like, I want to deploy this application and this database and this, and automatically it will happen in the background, right? So that's what I see with CI/CD for this.
Yeah, actually, I think one key thing you've talked about is Backstage by Spotify, easing deployment and easing how quickly software developers can set up development environments. Something I think we have been reading about previously, but yeah, it's a very interesting bit. Yeah.
Right.
Eric?
Yes, thank maybe just to pick up from maybe where Roger stopped is I think one of the focuses now was initially I think was mainly to get people into using CI/CD pipelines for them to deploy, but now that I think that needed is now ideal to see that we integrate into that pipeline other components that we needed to have there. And one of them we talked about is security, the tools to use. He mentioned a tool called Trevi. I think it's used widely both for image scanning, but I think I've also seen it used to scan misconfigurations within any Kubernetes cluster and how the cluster is deployed. And it can actually say that this particular configuration is a high risk. It can even go as detailed as to tell you that there is a particular, the access to this cluster is public, yet it needs to be private. Or even just to go as detailed, the infrastructure in terms of telling you that this particular subnet is having a public access to it, which we can. Also, maybe I think one of the recent news which we saw was Google taking on that or buying out that tool called Wheezy, which is I also see doing the same thing, although they bought it quite a big figure that many were shocked that they paid that amount of money. But it tries to show you that security within the cloud and also within the CI/CD pipeline is becoming an eye for everybody. I think the other two, I think many other people are using and has been in the market was that Snowcube to try and scan and ensure that whatever is getting into the cloud is actually what should be there. But how sometimes you get to realize that it's becoming everybody's concern was even to realize that Docker actually integrated one of their tools called the Docker Scout into even as the lowest level as the Docker desktop to ensure that even if you have an image on your laptop, you can actually scan and see which particular either Docker instruction brought in a particular vulnerability, and you would go as little as say, hey, particularly this line which says from this, it is introducing in one critical vulnerability, one medium one, or your particular installation of a particular package can sort this particular line is actually introducing this. So it went on to such tools, they go on to try and say that, well, we need to pay attention to each layer, each instruction, what is it adding into our environment? And then also it helps you when you are trying to fix it, you know where to go and change or how to change it. Thank you.
Yes, I think our experienced guest speakers have really hinted on a number of points here. But yeah, thanks for those submissions. But now I'm going to try to shift things a bit. Now, to shift things a bit, we have been talking of Kubernetes, high infrastructure. We even talked of 10K, right? Meaning US dollars, not 10,000 shillings. So these are all big budgets, right? Even one time I saw an interesting case study for Flutterwave, where Flutterwave is now using serverless on AWS, and they're saving lots of money, right? So now our key other focus is going to focus on serverless which is often hailed as the future of computing. So I want speakers to share your thoughts on the state of serverless and where do you see it heading this year. I think we can start with you, Eric.
Well, thanks. I think the first time when I heard the word serverless, maybe some of the people on the call could be at that stage. I was imagining particularly how do you deploy to where there's no server? And later I got to realize that the actually behind the scenes is so again the term is coming on who has the responsibility of that particular one. But it's more of another level after managing the service, because when the managing the service is ideally not your responsibility, but you know it that it's existing and it's running. Now for serverless is ideally trying to say, well, you only need to run this thing when there is need for it, or the request has come, we shall run it. The advantage is that the person managing it can do it in a flip second. Once you need it, it is there, and after that, nothing is running. But I think one of the key requirements for organizations to take on this particular concept or to utilize it is ideally the knowledge. I think we have kept on hitting about the skill sets or the skilling. Because in as much as these tools are there and they could actually save huge, significant costs, in an organization, in an environment where the team is mature, they have different specialties for the different roles. Because sometimes before even an application gets to be deployed, there's a solutions architect who has designed the architecture on how that application will be developed and it will be further deployed also. Now, it comes from that and says, what tools are they going to use? Or what's the strategy within the organization? If the strategy is to say we are going to ensure as much as we can for these applications to go and use serverless, and what are the benefits? Then the choices, how do you choose which particular project or product is going to use serverless? Now, depending on the knowledge that the team has on which tool can replace what, then it gets to that. I'll give maybe an example. There's a particular instance I think that we had one of my previous workplaces where a particular process was taking quite a long period of time. And without the mindset of the serverless concept, mostly you will say we will increase resource to particularly accommodate that particular operation. But then you realize that most likely that particular operation happens not every day, or it's not an everyday operation that happens. And then how do you break out that particular operation or an architect in a sense that you remove this particular function or particular operation to implement and use serverless concept? And then you will save, of course, in the end, you're going to save costs because you don't need those resources running all the time, since maybe you use it once a day, or some of those operations even they use like once a month, because things like generating reports, which maybe compute a lot of resources in terms of the DB queries they are running, but also maybe the computational resource they need in terms of cores and memory. But you may find you only use it once a month or twice a month. Why would you need to run those resources to wait for that particular time for you to use that particular? But the concept like serverless would come into the play such that you only use the tools which will listen to this function is needed, then you'll spin up the resources or use those tools, then run that particular task. So serverless is ideal, I think, going to be some of the things that people lean to in terms of saving the costs, but also it will require us to be knowledgeable and skilled to know that, yes, we can use this concept. It might be as easy as that, but when you know that your team knows it, then it would save you thousands, so hundreds of bills. Thank you.
Yeah, thanks, Eric, for that submission. Diana? You're muted.
So for serverless, basically, like Eric has said, you're just negating the management of the hardware to someone else, and what you're doing is definitely deploying or working on the code that you're supposed to. So some of the serverless functions, depending on which cloud provider you're using, whether Azure or Google or AWS, are really well spent out. So yeah, have to do your research and be able to know which one you're using depending on what your architect has prescribed for you. So that's my take on it.
Yeah. Kelvin?
Yeah.
Again.
Yeah, so current state of serverless. So what I would say is what I would say about the current state of serverless is that if you started out, if you look back at when public cloud became popular. Look, I'm looking at the big three because I had Salesforce, I had something already before. But if you look at the big three, let's say AWS, which was 2006, if I remember correctly, and Azure, which is 2010. If you look back, like in 2010, when Azure was when they started out, like when they started providing that service, and you look at the services that they were providing at that time, the services were so limited, which was the same thing also with AWS when they were starting out. Just a few services. They started with the base level services. And on some of those base level services, just like taking your app, let's say for people who are in Microsoft environments, running applications in .NET, taking the applications from IaaS, which is Internet Information Server, the Microsoft Apache version, whatever. Taking the applications from IaaS to web jobs, to workers. Back then, Azure App Service were known as workers. So also in a same sense, they would take their data to then Azure SQL. I don't know whether they started with on VMs. I'm not sure. I wasn't really working in IT at that time. But the current state, to go into the point of the current state, is like most of those services, because back then serverless wasn't like they had not like matured to that level. But right now, when you look the current state is like you don't need to have a web server that is running full time. Okay, I don't want to bring it in that sense, but like you don't need to have like let's say it could be a web server that is running full time, could be a database that is running full time on all the RAM that has been prescribed, that is been specified to it, and also the core that have been specified to it. Because in the cloud, things you are billed as they are running, you build by the hour. So at the current state is like most of the services, all services actually have a serverless. They have like a serverless offering. Just like in AWS, you find this Amazon Aurora serverless. In Azure, you also find they have Azure SQL serverless. Google Cloud, they also have theirs. I've not really used it, so I'm not so sure about that. But then you find that other services, the API gateway, it is serverless. In AWS, there's also what is this? Fargate instances are also serverless. So the current state is that whichever service that they bring on, that is like they try to bring in a serverless component to it, like a serverless offering, whereby you run it as when you expect, like, okay, as you at a time that you feel like this is when I would need it. So every service that's the current state. That's how I view serverless. Even when we go off like this top three, and you go to these data platform providers like Snowflake and Databricks, you find that they are also kind of like building up serverless services for event streaming and for the ETL processes. So that's how I see the current state of serverless. Every process that is out there, or any infrastructure service that is provided, there is like a serverless service that is coming up for that, or there is one. So where I'm seeing it headed 2025, it's still the same thing. Serverless for everything, as serverless as much as possible. But as the team, as my colleagues have shared, serverless is not everything. It depends on your architecture. It's not everything. Like, it's not that every time you're going to have to use AWS Lambda functions. If you have like event-driven processing, yeah, Lambda functions would work fine for you. But it's not that every time you're going to use serverless Amazon Aurora. Personally, in personal experience, we have a job that runs on Azure SQL Serverless. It runs every weekend. It's kind of like a heavy job, and the time it runs, we need lots of cores and RAM available, but it only runs on the weekend. So for that job, we kind of use the Azure SQL Serverless database option. So that's just to get to, you know when you need to use it. And but that's my thoughts on the current state and where I see it heading by 2025. See the same practice, know when to use it, and also know that if you're starting out on this service and it doesn't have a serverless option, most likely in the future there's going to be a serverless option for it.
Thanks, Kelvin, for that very insightful submission. Richard?
Yeah, so for me, serverless is really capturing attention recently, and for good reasons, right? But it's not yet mainstream, I would say, but it's evolving as we progress through 2025. It's evolving as organizations realize the benefits that it brings on board. So like, for example, scalability, right? You don't have to worry about adding, configuring your infrastructure servers to add more capacity. These things basically auto scale on demand, right? Serverless, basically. Then also cost efficiency, right? When you're dealing with, let's say, VMs, right? You even charge when your VMs are idle. Like, I mean, AWS charges when your VMs are also idle, right? The applications are not running, but it's charging for the whole VM, right? Whether it's running or not, whether your applications are running on it or not. But with serverless, AWS, let's say, or any other cloud provider charges based on like the requests that your applications receive. Let's say the invocations of Lambda functions, how many times you've invoked it. So it charges based on that, not on idle when your application is not running. Another benefit that I see is that it also reduces operational overhead. Your team will basically focus on innovating and bringing more features into your application than managing, let's say, servers, right? That's some of the benefits that it brings in. Also, it has some quirks, of course. Serverless, basically. If you talk about serverless, you'll be thinking about cloud. It's not very cloud agnostic, right? When you go to the AWS and develop maybe a serverless application using Lambda, it will not be as easy for you to move to, let's say, GCP, right? GCP has also its own flavor of serverless, maybe also Azure, right? So there's vendor lock-in in this, which is a setback when it comes to serverless. Another thing that maybe I would think of is maybe what's it? Also, like basically, like with this vendor lock-in, it's not easy for you to like. One of the things that I see beyond like let's say 2025, there should be like standardization when it comes to like serverless, right? There should be like a framework where everyone will harness and be able to use it and be able to make these applications, serverless applications, portable across platforms. So that's basically the trend I see with serverless.
Yeah, thanks everyone for
yeah.
Thanks everyone for those really insightful submissions. But I think one key word I've liked is vendor lock-in. I think we stick to using, as I think even Eric has shared, is, us moving services from one cloud provider to another seamlessly. But I think even serverless is evolving, that they're also embracing containerization. But I believe this is just some food for thought for people out there just to dig in. But I think one key, Kelvin, yes, you have your hand up.
Yeah, there's some thing that is on the cloud native landscape that I remember seeing. It's open fast. I don't know whether anyone has used it. I can't speak so much about it.
I have not used it, but I've seen it also open fast. I think it's one of the serverless frameworks. Is I think Knative also.
Yeah, I wonder if it
Yeah.
solves that lock-in. I've not really used it. The cloud native framework is.
It's trying to solve that. It's a serverless framework basically, and it's trying to solve. So it gives you like a tool, right, where you have to add plugins and whatnot, so that it helps you deploy across like these cloud environments. Yeah, so it solves that issue of vendor locking. It's kind of trying to solve it. Yeah.
Just for users out there, you can read about OpenFast, open, then FAAS. Yeah, serverless functions made simple. But yeah, I think to proceed, all this, when we talk about serverless, we're trying to cut costs, right? So in regards to cost management, which is a very serious growing concern when it comes to using the cloud, because we have had people move to the cloud and still shift back, right? So what are some, I'll request every speaker to share 2 insights, 2 innovative strategies or tools that they see can help organizations optimize their cloud spending this year. We can start with you, Rogers.
Yeah. So for us personally, my organization, we've been using reserved instances, right? If you know that you're going to be running this workload for this amount of time, and you're sure for less than 2 years, it's better for you. It's better off like reserving these instances, right? So you get benefits of cost savings as you proceed. Then also, we recently changed our clusters from, we've been running like VMs that are constantly running, but now we're using something spot instances, right? So for less demanding workloads, you can start thinking about spot instances. Also, we've also developed an approach whereby during off-peak hours, let's say during office hours, we turn down some of these instances. Let's say who will be, using some of these, especially lower environments, let's say QA, UAT, where we know that most of devs are offline and they're not using. So we turn off most of these instances. We have a script that automatically does that, right? So these are some of the things that you can maybe keep an eye on and start implementing to reduce costs when it comes to cloud. Yeah.
Thanks. Diana?
So some of the ways to reduce the costs, I heavily use Azure. So one of the ways when you're moving your infrastructure from on-prem, let's say to Azure, use the Azure hybrid benefit. Here, in case you have some licenses that, some server licenses that you're using on-prem, you can apply them on the cloud and get a reduced cost for whichever resources you'll be running. You can also use saving plans. Here, if you know that you're going to use your servers for, let's say, a specific amount of time, let's say for about a year, you can reserve it for that amount of time and be able to get it for a reduced cost. And also then, if you're already on the cloud, there's what you call the cost advisor. It keeps on advising you on which resources you've used, and you can also apply budgeting depending on what your cloud budget is. You can apply budgets, and then it keeps on alerting you of how much of your budget you've spent, how much is left, and you can be able to adjust your resources accordingly.
Yes, thanks. I think one keyword is we need to stick within a budget while working with cloud. But thanks, Diana. I will ask Eric.
Well, thanks. I think maybe just an addition with what the previous speakers have already said. One of the other which I find it it's in the mind. So we need to do what we call cost visibility to the person who are speeding up. I liked throwing that word, okay, the cost of the previous month, and I would come open and I say, last month we spent this amount of money. And I would make sure I translate it. If it's a Ugandan team, I will translate it to Ugandan currency such that you know how many millions or thousands of amount of money was spent. Like that, then it plays into your mind the next day when we come and we say, look, we spent this amount of money. Is it worth it for this environment? And because there are many different teams we answer to, maybe in our workplaces. Sometimes you may have the auditors, sometimes you may have the compliance team who will just come and they say, by policy, you should have, let me say, DR site. What's the cost for running a DR site? Or when do we need it? So some of those things then begin to say, okay, do we need to change the policy of the requirements we need to maintain? But then the other thing is monitoring. So monitoring helps in terms of knowing, okay, we spent this capacity. How much did we use? Or how much do we actually use? When have we ever reached even just 80% of the resources we spend up? So it gives you an overview of actually the resources you actually need, because sometimes you most likely are going to find yourself that you actually oversized of what you actually need. So because you are monitoring, you actually get to realize and say, look, okay, if maybe you say you needed 16 cores for this particular instance, and you find you didn't even reach 80%, even 50%, you never crossed it. So is it time then to downsize this particular resource and use the number? Or sometimes you may need that you by default you say that this has to be running in 3 availability zones. Or maybe you find it's not 2 would be enough. But also then the other one is we find we have a lot of environments. You have dev, you have UAT, maybe QA, then production. Other than production, going downwards, do you need that environment running 24/7? And I think, for example, you might find that sometimes some people are not doing UAT every day. So how best can we utilize this environment to set it up so that it is UAT? Yes, it is UAT, but we only spin it up when it's needed. And that's what takes me to the very key concept, which is infrastructure as code, which we have been hitting about. But sometimes you may find some teams, if you are not using infrastructure as code, it will be very hard for you to say we switch it off or we destroy that environment when we don't need it. Because the day you want to spin it up for the UAT guys to do their UAT, you may ask for a day or you may ask for a week, and they still don't have that time. The code has been, the developer has finished, we want to perform UAT tomorrow. How quickly can you put it up? So if you have it as already infrastructure is already coded, you will tell people, oh, give me these few minutes and they'll have that environment back up and they'll do their UAT. Once they finish, you say, well, this environment is going to go down because they have now comfort that, well, when we need it, it will be up. So they don't have to say, leave it running because we may need it tomorrow. You say, if it's tomorrow, yes, in the morning, let me know what time you need it and it will be up. So I think some of those are the key concepts or strategies to use to manage, because cost may not be one particular thing you do. You may have to do a couple of things you have to merge to ensure that you cut that cost of the different angles. Thank you.
Yes, thanks, Eric. Kelvin?
Yeah. So I have a lot to talk about the cost management, but much has been shared actually by Tim. So actually, cost management, one of the things I've seen that the starting point with cost management, usually the upskilling the team, especially the infrastructure team. I've seen a couple of teams that get into the cloud when they do not fully they have not really taken courses to do with the different services that they're going to implement, understand the cost implications. So I think it starts with the skilling of the team, knowing what they are going to implement and the cost implications. For example, I happened to I was working on something, was consulting with someone, who actually really loved to move on to the cloud and start up something, like do something in the cloud. So when I went into I told them what I need to do, but when I went into the environment, I found that they were using, I think, multiple availability zones, like Erica shared, and that was, and according to the architecture. So also you have to understand the architecture of the application or whatever you want to implement, maybe the infrastructure. Understand it, what's the purpose behind, what kind of availability do you need? Do you need like that military grade availability? Do you need those military grade tools? Like, you need to understand the architecture of what you're implementing, because the bigger you go on the cloud, the more costs that you're going to incur. So at that point, I noticed that actually they were using multiple availability zones, which they did not need. They weren't running a production workload. And so they were getting 3 times the cost, So that took me back to, okay, I think they needed some like fast capacity building towards the cloud and understand some of the services and how they work. And then they also understand the cost implications of each service and how to control the cost of that service. So there's a lot that can be done. Rogers shared something to do with spot instances. Yeah, we actually also use spot instances. They're quite useful. They're quite useful because, like right now as we speak, those instances are not running because no one is working at the moment. But come Monday, Tuesday, whatever, towards the weekend, like they are quite busy. They are working, and and they're also only working during working hours, so they're not always running. So that comes up with the skilling and also understanding the architecture. But there are many other tools that you can find within a cloud platforms. There are budgets to help alert you in case your budget is, maybe you've reached 50% of the budget, and it's yeah. And also there's those advisor tools that Diana shared about, like Azure Advisor. But cost management it's a big thing. But most of the times, even me myself, I've been a culprit to poor cost management. There's a time I was implementing, there's a service I was implementing. It was a different team. It was to do with storage account. It was to do with storage account. So I had worked with the smaller teams, and storage accounts weren't like really accumulating much of the cost. But I happened to work with a team which had used to make so many queries on the storage account, and I hadn't really calculated that it would be that much. So I didn't know like how many queries are going to be made. I just went in. I'm like, I think it's just going to be normal. Like Rogers shared, I think we're talking about serverless, knowing about the number of invocations that you're going to have on a Lambda function. So very many invocations may not really call for you to use a Lambda function. Depends on the architecture. Like, yeah, very many of them. So I was also blind of the fact that this storage account was going to have so many queries, like so many requests done to it. So I was blind of the fact. So it comes back to the skill in knowing what you're going to implement, the architecture. Then you also understand the cost implications that this is going to cause. Otherwise, you're in for a shock towards the end of the month. But there are also tools to kind of help avoid that, like the cost budgets, those alerts and all that. Yeah, but you just want to be prepared before that ever happens, because yeah, it's not good to pay for a bill that you've not planned for.
Yes, that's really insightful, and also the cost is really big when it comes to cloud. Thanks to the speakers again for really going in depth into this. Yeah. So I think one of the things we have, I think key pointers we have added to infrastructure as code and application monitoring. So for this, I'm going to ask Kelvin and Diana to talk about application monitoring trends and tools or practices they think that will become a standard this year. Then I will request Eric and Rogers to talk about infrastructure as code, because it's fundamental to modern cloud management, and we have seen it's also key when you're implementing cost savings, right? So probably they will dip into trends they see this year. I think we should start with Diana and Kelvin.
Yeah.
Okay, for the application monitoring tool trend I see this year, basically we have the Datadog. I think that's one of the high ones on the list, since when you're in the cloud environment, you're supposed to have monitoring and observability, not only for the cost that we have talked about, but also for your infrastructure. Then the other one, I think it has skipped out of my mind. You can first proceed from here, Kelvin.
Yeah. So next generation application monitoring tools. Personally, and many other people use the Gartner Magic Quadrant. It tends to be accurate because it's like where peers review a tool and submit reviews about a tool, and also where experts review a tool. So I currently we use Datadog, but I wouldn't like push for someone to use Datadog because it's expensive. And yeah, it's quite expensive to use. To me, it's expensive. So why I talk about Datadog, I'm also going to talk about an open source variant that is quite good, that is also being at the top within the Magic Quadrant. But Datadog is not the only tool out there. There is Dynatrace, there is New Relic, there are others. But why I kind of put it into that pyramid of being a next generation application monitoring tool is that there is much of integration with AI that is being done, and there's also lots of features that are being added that you don't normally typically find in another monitoring tool. So they kind of like try to build this tool to be they try to understand the customer needs, but it's expensive. But I would really recommend someone to look at it if they are really willing to pay for the price that I do. But some of the things that you find in there, for example, when we're starting this session, I talked about a watchdog, Datadog watchdog, which helps to show you the trends in the logs, metrics, and traces that show like a discrepancy between the performance, let's say 1 week ago and right now, and kind of help you to drill down and know what the cause is. And also there's continuous profiling as well. Continuous profiling in a nutshell is basically like it analyzes the code and shows you where in the code could be bringing in performance bottlenecks. So for example, you find that devs maybe pushed some code, some poorly written code that is not, there are different ways of coding. So there are people who code with performance in mind, but there are also people who code just to let a feature out. If it is working, well, that's good, that's fine, let's move on. But there are also those people who code with performance in mind, like, okay, I've implemented this feature, it's working well, but how is it consuming the system resources? How will it perform if it is storing this amount of data? So with continuous profiling, it can help you to identify those performance bottlenecks in the code that was written. There is just so many features to talk about it, but I don't want to zero down this application monitoring to Datadog. That wouldn't be correct. It's just that it's what I use, and I've seen it being different from other tools. But you find that there are other tools like Prometheus and for the metrics and Grafana. Just that you find a tool that Datadog, they bring in all those tools into one box. But leaving Datadog on the side, if I'm to go open source, Grafana Labs is really doing something good. Actually, when you look at the Magic Quadrant for 2024, the Gartner Magic Quadrant for application monitoring and observability for 2024, Grafana Labs is actually part of the leaders right now, and they have like different tools that you can use for application monitoring and observability according to your needs. If you want to do a UI, what is it called actually? if you want to do like UI, like, you know, seeing how the users interface with the application in the UI, like what's breaking down in the UI, like, you know, the crashes, what's really crashing in the UI. There's all those different plugins within Grafana Labs that are being developed, as well as we find them in Datadog, but talking about Grafana Labs here because we can do this open source. It's just that you have to plug in all these you know, all these features into all these plugins into one tool. Like you bring in the Grafana for the visualization, Grafana Alloy this side, then you bring in Prometheus for the time series database, then you bring in Grafana Loki for for the logs. Okay, forgive me for using all these technical terms, but that's just how the tool works. So the practices that will become standard by 2025, I think there's going to be continuous use of AI to help us predict application performance, application performance according to how the application is been performing for, let's say, the last couple of weeks to you know, to the current date, and also future if things continue being that way. Yeah, that's basically it on what I say about application monitoring.
Yes. Thanks, Kelvin. I think now we're going to cross over to.
But just a disclaimer, I'm not marketing at all. I'm not marketing Datadog. It's just a tool that I use, and I'm open to using anything. Actually, personally, I want to use New Relic for a project, some personal project. I want to use New Relic. It's just that New Relic has a free. There's a free user. There's a free whatever for users that gives you all the features. Which I don't find it. Yeah, there's a free tier that gives you all the features. They just limit you on a number, on the data, maybe 5 GB of logs. But this is a simple application I'm working on. I'm okay losing the log retention. Yeah, but yeah, don't fix on one tool. I've just shared this tool, but don't fix on one tool. You can assess multiple tools and see what works for you. It's just that this is an industry leader, along with New Relic, Dynatrace, and Grafana Labs. They're like the industry leaders in application monitoring and observability. Thank you.
Yeah. Thanks, Kelvin, for that. Thanks, Kelvin and Diana, for the insights on application monitoring. Yeah. And as the Kampala Devops community, we do not endorse Datadog. We're just sharing knowledge. This is no endorsement. Yes, I'm going to cross over to Eric first, then Rogers to talk about infrastructure as code. And they see this here in relation to that. Eric, the floor is yours.
Thanks. So maybe I will pick on since we have already mentioned that infrastructure as code is ideally a requirement ideal for the modern management of first the infrastructure, but also the proper management of the cloud environment. I want to stress, I think, the point of adopting it for places where maybe or engineers within that space who have not yet taken it as a standard is that one, it simplifies a lot of other dynamics or aspects within the management of this environment. It will be easier for you to implement security. It will be easier for you to monitor or to manage your cloud costs. It will be easier for you to execute work on time, and also to the requirement of the number of people that need to manage a particular application will be less if you take on this trend or this approach. There are many tools. Some of them are widely popular more than the other, but ideally they achieve the same concept depending on the knowledge and the skills that people have. We have tools like Terraform, CloudFormation for those who are using AWS. Terraform, the benefit maybe with it is that it is multi-cloud, so it's not tied to one cloud platform, so you have no vendor lock-in. If you learn it, then you can easily switch it from AWS to Azure to Google, because it can ideally integrate with all those particular service providers. AWS, of course, has CloudFormation, but specifically for AWS, so you cannot use the same code to run that application in Azure. AWS also has AWS CDK, there's Pulumi, and quite a few other tools. They are very important because you can actually know how long the application will take to come up if you are using that tool, and you can comfortably tell your team the application will be back or to be up in the next 2 minutes or the next 20 minutes. And it becomes easier even to implement CI/CD pipeline end to end because you can actually use that infrastructure as code script to be part of the pipeline to start that deployment or to deploy the infrastructure first, then deploy the application on top. And those tools enable us to, one, to utilize the skill sets in the skill sets, which are the software development or the coding skill set, or even standards within the organization, to even be implemented within your setup of the infrastructure. So adoption for infrastructure as code is really key. It is easier to know to version control the infrastructure and know this is what we had before. Currently, this is what we have, which you wouldn't be in position to do if you're not using that concept of infrastructure as code. So there are quite many benefits using that particular concept of infrastructure as code. And if you needed 5 engineers or you needed 5 days to manually set up a particular maybe complex project, if you had coded it, the next time you tell them, give me a few minutes and it will be back up. And well, sometimes you may look like a magician within your workplace, but yeah, it is just idea of taking on the concepts which will easily save you a lot of time and have time back to you to do other things, to do more learning, more skilling than spending the whole day trying to remember which particular firewall rule you should have raised and it's blocking the application from starting. But yeah, so infrastructure as code is very key for us to utilize or to be in position to be efficient and to do a lot more in the cloud. Thank you.
Yes, thanks for that, Bridges.
Yeah, so I think Eric has already spoken about benefits that infrastructure as code provides, but I'll need to add on the version control. So since most of these applications, technologies like Terraform are, written declaratively, so they're posted on GitHub, you'll be able to reap the benefits just like when you're dealing with your application code. Like, for example, pull requests, right? PR reviews, rollbacks. You'll be able to roll back, commits. So those are kind of the benefits that you can get from infrastructure as code. And aside from that, I'll talk about the tooling without focusing specifically on the cloud specific tools. So I see most of the tools that are being used in infrastructure as code. I see Terraform, like the main tools that I see are Terraform and maybe Pulumi. I think for most people gravitating towards Pulumi nowadays, I think because of the licensing issues with, I think, Terraform, right? So I see people trying to, move into Pulumi. So it's gaining traction. When it comes to best practices, I already mentioned, I think, policy as code a number of times. So if you can bring this into your CI/CD pipelines, your infrastructure as code pipeline, basically the one that deploys your resources, it will really help you with, let's say, some misconfigurations. There's some juniors that we have in the team. They can make really serious errors, and they will not be able to. If you don't have this in place, you might not be able to detect this until it reaches in production. It has caused a lot of chaos, right? So with something like this, you can easily, safeguard yourself from simple misconfigurations sometimes that people as humans do. Another thing that some of the best practices I also see is to implement GitOps also for this infrastructure, right? You have GitOps for deploying your applications, and you can also implement something like GitOps for your infrastructure using Argo CD or Flux, whichever tool that you may prefer. So with that, I think those are some of the best practices when it comes to infrastructure as code that I can think of. Yeah.
Yes, thanks for that. So I think as we come to the close of the session, so I'm going to request a speaker to make a bold prediction for this year, and as well as share one skill an engineer should learn. I'll start with you, Rogers.
Yeah, so with the rise of AI, right, I think we'll be seeing, I think one of my bold predictions is that we shall be seeing autonomous cloud platforms, right? We shall see these cloud providers integrating, like, let's say, AI agents into their platforms, right? With that, we shall maybe be seeing uh, these cloud platforms being able to auto provision infrastructure without any human intervention, maybe through maybe our natural language, prompts and whatnot. We shall maybe also see with this AI self-healing system, right, in the cloud. So services will be able to self-heal, things like that. With that said, I think what was the question again?
Your bold prediction for this year and the one skill that an engineer should focus on this year.
Yeah, so with the skill, I think the main skill that I would see is that we should really learn AI tools. We should learn to work with these AI tools, right? We should learn working alongside these AI tools because they'll actually augment, or enhance our existing skills. Yeah, it's not going to like replace us, like maybe some people think. Yeah? It will just enhance our existing skills, and so it will become as critical as, let's say, coding, for example, your coding skills. So the sooner you learn these AI tools, the better for the future. Yeah, I think that's all for me. Yeah.
Yes, thanks for that, Diana.
So my bold prediction is in this age of AI, even though they say some people won't lose their jobs, I don't think cloud and DevOps are going anywhere because those AI agents, they need their infrastructure to be able to run those models. Then for one skill that everyone should learn, I would choose Linux or scripting because in the age of infrastructure as code, as my colleagues have mentioned, when you're doing that automation, you're going to need scripts for it. So you really need to learn your scripting.
Yeah, thanks for that. Eric?
Bold prediction. I think we'll have more advanced capabilities from there. I'm imagining, or if it's not already existing, maybe I think we'll be in position to submit an architecture diagram to a machine, an AI tool, and it will be able to create a script that provisions it end to end. A skill set I would recommend that it is very key. I highly recommend programming skills because of the benefits it brings. Some of them are more with the characters it will have you develop. One of them is you find comfort in dealing with errors. You will not get intimidated with when things fail, which 90% of the times you will find that you will not be an engineer and something hasn't failed. So you will be required to fix when things have failed, one of which programming introduces you to such kind of things where you learned how to fix errors, debug, and look at logs and find what is. So there are many languages you can choose one so that you just learn how to write code, because even infrastructure as code, you are going to write code. Configuration as code, you are going to write code. So MLOps, you cannot utilize it if you're not going to be writing code. Or GitOps, you're not going to find ways of utilizing it if you are not writing code that is being used. So it's one of the skills that I encourage people to have as much as they can. Thank you.
Yeah, thanks for that. Kelvin?
Yes, the bold prediction is for this year or?
For this year.
Yeah, I don't have a much bold prediction. But AI agents are gaining so much traction lately. Maybe they could be.
Hello, Kelvin. Did we? Could I request probably someone to say?
I think I've lost him.
I think we have lost him.
Yeah.
Yeah, I think it's an internet issue. Yeah, but as we await Kelvin to make his final statement, probably I will look into the chat. Feel free to paste your question in the chat. Yeah, so one from Onjia Emma. Hello all. I think with time, the name should change from Kampala Devops to UG Devops. I think we can all agree. Kelvin is back.
Can you hear me?
Yeah, it's a can.
Can you hear me?
Yeah.
Okay.
Yeah.
So yeah, I was saying maybe you can hear me well right now. Okay. Yeah, maybe AI agents. Maybe there is something, another layer we're going to see. Maybe some AI agents doing some more work. Last year I signed up for this Devin thing, but I don't know. Maybe those guys were just getting money from people, but I never got to get early access to see how it works. But could be some AI agents. I don't really have a concrete bold prediction in that sense. The skills, my skills are more similar to what Eric has shared. I've happened to speak with a couple of people, especially people that have not got into the field, and they think that with AI, they're not going to need to learn how to code. I've realized many people think like that, but let me tell you, personally, I would say I work with a person who is pretty good with code, and I'm also just not at the same level as him. But there are times when I'm given a task and I execute it. Yes, and I use all the tools. I use AI and I execute something, and it is working pretty fine. And then when I go into a review and we're making improvements, I see he's actually making it way better. Like he's making it way better. Like, oh, this is actually a better thought process. And he's, engineering it in a much better way. So AI has not really solved like my problem. Okay, it has solved my problem in a simple way, but the additional complexity that is added is, there's some kind of improvement that is being made. So software development is still a critical skill to learn. And especially when you're in DevOps and you learn software development, you find that you can relate more with developers. Like everything that is going on, you understand like what is going on, what is creating this performance bottlenecks. Like you're not in the dark, you don't know what's going on, you know exactly what is going on. If a database query needs to be optimized, you're looking at the query like, this query is not the right query, it's not making the right calls, it's causing the CPU to go up. So if you know the software development and you do some code yourself, it's easy to track that and become a better DevOps engineer. So the coding is still there, and some of my fellow speakers can actually agree with me. Sometimes you look at very many DevOps jobs and they mention proficiency in Python, proficiency in this. That is not there by mistake. It's just that it makes you a better DevOps engineer. And also adding on to the skills like MLOps is kind of growing in its own way. MLOps is basically like DevOps, but for the machine learning application. So you maintain the model registries, you maintain the entire pipeline that the models go through from experimentation to production. So that's a need that ML engineers need right now. Like they need like DevOps engineers to help them out with the infrastructure part of things, and to make sure that the pipelines are well set, just as they are with these normal web applications. Yeah, some bit of data sometimes come in once in a while, setting up the data infrastructure, setting up Databricks, let's say Databricks, clusters. You find yourself, you're a DevOps engineer, but then you're going in Apache clusters, you're going in Databricks clusters. So then you're trying to understand, how is this pipeline working? Like, why does he want to have this pipeline set up like this way? So you find yourself like trying to learn something in there. So the skills, those are the skills, software development. Yeah, you still need the DevOps infrastructure skills, but just add on a bit of software development. And with software development, those other skills to do with MLOps and data ops, whatever, they kind of come in easily. And also when you're doing that infrastructure as code, you're coming from the problem solving mindset that a developer has when they're trying to build out a solution. So yeah, those are the core skills. It can sound as a lot. Most times I don't want to tell this to people, but back then, personally, when I was starting out in DevOps, I started as a sysadmin, and they used to tell us, you guys need to do automation. Used to use PowerShell. You get used to do Ansible. I'm like, I can just do my click here and let my things be. But then with time, you found that, this thing is really growing big. It's growing big. I really need to automate this thing. So we found ourselves naturally going into that mindset of writing the code, sitting down and thinking of a PowerShell script that is going to take you like months writing, but then it's going to save you like, let's say, weeks of setting up the infrastructure from scratch. That's my input on the skills and yeah.
Thanks to all speakers for that submission. Yeah, I know we could go long, but in the interest of time, DevOps engineers, cloud engineers, we like to keep time, right? Even the bills come on time. So for this case, we are coming to the close of this session. Probably for Q&A, there are just a few questions in the chat, probably changing the name from Kampala Devops to UG Devops. So this is the heartbeat when it comes to the legal side of it. Using Uganda in your name, I think you can have issues with URSB, Uganda Registration Services Bureau. If you notice, few companies have that name, say, at the start, because it's more reserved for government. Yeah. Then probably John Oliver asked, how can I get started with DevOps, and is there any mentorship program? Probably I'm going to ask one of the speakers to take it on. Probably Kelvin, Rogers, you can share your insights on this. Or anyone? Probably just a few points, short brief points.
Yeah, how can you get started with DevOps? Yeah, basically DevOps, I would like to stress DevOps is not really entry level, right? You can begin, but it's not meant to be entry level. Most people you see in DevOps either came from an infrastructure background, just like I myself, maybe Galabuzi also mentioned, Kelvin. Then also from the development, right? You can transition from development to DevOps and learn this all the workflow. So that's something not doable with the right, structure, the right, let's say, preparation. There are platforms like Code Cloud that can help you, get up to speed with DevOps, right? You can quickly join their mentorship program. There are also some, courses or tutorials on platforms like Udemy. But I would recommend something like Code Cloud because it follows a structural, structural approach. You start from this, then you move to this, then C, then D, then you're here. But when you just follow tutorial, let's say on Udemy, you as a beginner, you might not know what you really want to succeed in DevOps or to become a DevOps engineer. So you end up stuck in this process of looking for more, courses that are picture, right? Or how to, come in and work together. So with that said, you can start from basically the fundamentals. If you're just starting out, you can maybe learn Linux, right? Most of these systems learn the fundamentals. The fundamentals will always be the same, right? Don't worry about the new tools, the new shiny tools like Kubernetes when you're beginning, like maybe Terraform, right? Start logging into these cloud consoles and click ops, right? That's what they say. Don't worry about the infrastructure as code. Yeah, click on this deploy VM, destroy it. Use your mouse to click things. learn Linux, like I say, it's basically the foundation of a lot of things because the system that you'll be troubleshooting, optimize some of these things. And, like things like containerization, learn about Docker, which is the main thing. Uh, uh, you'll find that when you learn the fundamentals, it helps you build up on these other new tools. Let's say if you learn, let's say, Linux really well, you'll find that using something like Docker makes much more sense, right? You'll be able to run these containers. You'll be like, okay, I was using a Linux VM, and I think this Linux VM is in something called a container. So I can easily go into the container. You'll see the file system is exactly the same as when it's in a VM, right? Then when you think about that, like Docker, then you start thinking, okay, I have now this, I can run this Docker container on my local machine. What can I do? I want to run this on a lot of servers. Yeah, you cannot go into each server, then run this Docker thing. Then you start thinking about Kubernetes, right? Start thinking, okay, I can now see where Kubernetes comes into the picture, right? So I advise someone who is just new and trying to learn, DevOps to start in that. The basics, like you see, let's say you see Galabuzi, you see Array, you see, any other. Hello?
Are we
Can you hear
network?
me? I think I'm having some network issues. Please confirm if you can hear me.
Clearly. But yes, okay, ladies and gentlemen, I would say in the interest of time, I think for questions in relation to careers and mentorship, I would say careers stick to using LinkedIn sites and other platforms for now. But I think in the interest of time, I'm going to share closing remarks. I'll share a vote of thanks to our speakers. Thank you so much for creating time. Thank you for being positive when I reached out. Yeah. And hopefully we can have you probably get to share more knowledge on different aspects of DevOps because the hunger for knowledge is evident. Yeah. And I would say for those, I'm sharing my screen. For those who you can keep tabs on the recordings that are always uploaded to the YouTube channel, which I'm sharing on the screen right now. And also, we recently launched Substack. So Substack is going to enable us to write articles on different topics. So hopefully, I'm encouraging DevOps engineers on the call and those in the community. If you have any article, please feel free to share it. You can share it on the Substack community, such that we can continuously engage. And I also encourage everyone to get to subscribe to Substack, such that we can still keep the conversation going. And on LinkedIn, we can still get to connect. YouTube is there for these sessions in case for future reference. Yeah, but once again, probably Kelvin has something to share. Kelvin, please proceed.
Yeah, maybe that question that someone asked, because I'm sure that's a question that would come back again. Maybe you can publish it as an article, how to get started in DevOps, something of that sort. Because I'm sure that's a question that would come up in other sessions as well.
Yeah. So in regards to that, we shall be cooking those articles. And collaboration is welcome. Feel free to send in those articles. We shall get to publish them and share them with the community. Yeah. Ladies and gentlemen, I think at this juncture, I'm going to call this an end of our session. Thank you again for everyone for creating time. Thank you, Kelvin. Thank you, Eric. Thank you, Diana. Thank you, Rogers. We appreciate big time. And we hope through the year we can have more sessions. Then we are cooking something, but yeah, we shall share more of that. It's good to know to share it, right? Yeah, but we're cooking something nice. Yeah, we're cooking something. We are cooking. Right now we have just turned on the burner. We need to get ingredients and everything, but you're cooking up something nice here. Thank you, everyone. Let me wish you a lovely weekend and great time ahead.
Thank you. Thank you, everybody.
Thank you, everyone. Thank you. Bye.
Thank you. Bye.